previous session, we discussed regarding marks, verilog code, and linear testbench. Now, today's class, we are going to discuss working of decoder, verilog code, linear testbench. If you see this block diagram, it is a 3 to 8 decoder, right? Here you can see it is a 3 to 8 decoder. In generally, in decoder has a n inputs and 2 power n outputs. If you observe here, it has a 3 inputs and 2 power 3 outputs. 2 power 3 is nothing but 8, right? So that's like if you see here, it has a 8 outputs, right? Based upon the inputs, the output will comes. You can see in the scope table, if you observe, if all the inputs are 0, at that time, Y0 pin will active. If it is a 001, at that time, Y1 pin will active. If it is a 010, Y2 pin. If it is a 011, Y3, 100, Y4, 101, Y5, 110, Y6, all ones, Y7. Right. This is the working of decoder, right? Now we will see how to write code for it. Okay. I'm just going to my tool and I'm opening my one file. Okay. I'm giving a keyword module. Okay. Saving my file. Okay. Now my file is saved. Now I'm declaring inputs. I have a two, I mean, I have three inputs. So I'm declaring here uh, with an array. So I'm declaring 2 down to 0. It is nothing but a 3. And I'm giving the name as A for my input. When it comes to output, I have a 8 outputs, right? So I'm again taking an array 7 down to 0 and I'm declaring my pin as a Y. Okay. Now I'm using always keyword. At the rate is nothing but a even. Inside the brackets and putting a star, it consider all the inputs. Okay. Here I am using APS. Case is used to check the multiple combinations. Here, when it comes to decoder, based upon the input combinations, the output will come by. So we have to find the combinations for input, right? So inside the brackets, I'm taking A here. That's the reason. Okay. Now, what is the size of the A? 3, right? So I'm taking 3. Here I'm representing in a binary. So I'm taking as a B. If all are zeros, what will be the output? Only uh, the Y0 pin will have to remaining dollar in offset, right? Here, if you see, my output pin size is 8 and I am representing in a binary, so I am taking as a B. If you see here, I make my Y0 pin as 1 and remaining dollar 0 according to the working. Now I am taking one more combination 001. At that time, my Y1 pin will have to remaining dollar offset. Right. Now we are taking one more combination 010. At that time, my Y2 pin will have to remaining dollar in offset. Okay. Now we are taking one more combination 011. At that time, my Y3 pin will have to remaining dollar in offset. Now if you see, I am taking one more combination 100. At that time, my Wi-Fi pin will have to remaining dollar in offset. If you see here, I am taking one more combination 101. At that time, my Y6 pin will have to remaining dollar in offset. If you see here 110. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 1 0. 1 Last second pin will have to remaining dollar in off state. Now, if it is all ones, my last pin will have to, my MSP pin will have to remaining dollar in off state, right? So here first, uh, I need to close this case, right? So I'm giving a one more keyword and case. After that, I need to close this begin, right? Begin and the module, right? Now my code is completed. Now I saved my code. Now I need to compile my code, right? So I'm going to my uh, terminal and I'm giving here command reload decoder 328. This is the name of my file, right? Verilog file. So I'm just pressing an enter. If you see here, my code is successfully compiled and it has zero errors. Now what we have to do, we have to write testbench file, right? So I am taking one more file. Just if you see, I'm taking one more file and again I am giving the module keyword. After that, I am saving my file. Let's free to use tbb.it. Now my file is saved. Now I am giving my module name. Let's free to use tbb. When it comes to the uh, linear test bench, when it comes to test bench, we have to be declared reach for the input variables. What is the size of my input variable 3, right? So I am declaring 2 down to 0, 8. When it comes to output, we have to be take as a right, down to 0, y, right? Now we have to be instantiate our design. So for that, whatever the module name of our design, just copy that module name and paste it over in your test bench. After that, if you have to be give a name, whatever name you want, you can give it. Now I'm instantiating my design. Okay, of y. Now here I'm using the initial keyword. The keyword is nothing but it starts from 0 nanosecond. Now I need to pass the inputs, right? My input variable is A and size is 3, right? Here I am representing in a binary format, so I am giving here B. After passing one input, I am just giving some delay. After I am changing my input, here I am checking the all the combinations. If you see here, 0 1 0. After again I am giving some delay. Now one more combination, 2 1 0 0. Again some delay, 0 1 0. A equals to 3 B 1 1 0. Again delay, 3 B all ones. If you observe here, I given all the combinations and I'm ending and I'm using one module. Now my code is saved, successfully saved. Now I'm again going back to my terminal. Here now I need to compile my test bench file. So I'm giving my test bench file name. If you see here, my test bench file name is decoder 3 underscore 8 tbb dot e, right? So 3 underscore 8 tbb. I just press an enter. Here, if you see here, uh, my code is successfully compiled and it has a zero errors. Now I need to simulate my test bench, right? So I need to give using command and my module name, test bench module name. I'm just copying my test bench module name. and press it over here and press the enter. Now, if you see here, uh, it will open this window. Just right click on it, add to wave, all items to this one. Okay. Now all the inputs and outputs were added in the waveform. If you see, our input is A and output is Y, right? So we are already given our inputs. So we need not to force the values. So we just press a run command. This is the run command. I'm just pressing it once. If you see here, according to our design, if all are zeros, Y0 pin has to be active, remaining all are in off state. It means this first condition is true. Now comes to second condition. If it is a 001, my second pin will active. This condition is also true according to the design. If you see here 010, my third pin will active. Here that only coming. It means this test case is also passed. Now if you see 011, at that time my fourth pin will active, remaining all are in offset. If you see in the output here, that only it's coming. Now when it comes to 100, at that time my fifth pin will active. If you observe here, my 15 my 15 will come in 1, remaining all are 0. It means this test case is also passing. Now when it comes to the input 101, at that time my 16 will have to remaining all are 0. It means this test case is also passed. Now when it comes to 110, at that time my 17 will have to remaining all are 0. Here if you observe here, it is coming like that only. Now check one more last test case, all are ones. At that time, my last MSP pin will active. It is nothing but 8th pin, remaining all are 0. It's coming like that. Okay. Uh, this is how we have to be verify our design by seeing the waveform. Okay.